So in problem number 19 from section 3.1, we're going to tackle this problem that we're actually going to see again and again and again. And that is, given a curve, and a point on that curve, find the tangent line, okay, and then let's say A, the tangent line, and B, the normal.
Yeah.
Okay. Now, this problem is actually very, very similar to a problem that you did a lot when you were in Algebra 1. And that is, the Algebra 1 version of this question is, given a slope and a point, find the equation of the line. You agree there?
Yeah.
That you did that problem a lot in Algebra 1?
Yeah.
Okay.
What I remember.
So there's typically, the way we handle that is that you either go back to y equal mx plus b, and you use that form. But actually, I prefer a different form. This, of course, is known as the slope-intercept form of a line.
And then you prefer the slope form.
I prefer the point slope form. Now, I grew up learning it like this. Where the slope is given as m and the point is given as x1, x1, y1. Our book, though, tends to write it this way. Where they just put the y on the other side. They're algebraically equivalent. Right? So, I'm going to tend to write the solution here. And now let's combine the two ideas. We have a function. That function graphed looks like that. And there's a point, let's say it's 1, 1 there. And through that point, we would like to draw that tangent line. Line that touches the curve once, mimics the slope, right? Well, we know the point part of that linear equation. It's 1, 1. So we know the x1 and the y1 in this form that we're going to fill in. The question is, what's the slope? The answer is, we'll find it by looking at the derivative.
We're going to use the nothing limit.
And at this point, we don't know the shortcuts. So we're going to pretend that there's no other way to find it other than to use the definition of the derivative. Would you like to use definition 1 or would you like to use definition 2?
1.
Definition 1 it is. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That's without any augmentation. That's straight definition. But we know that if we define our function as being the cubic function, that this turns into x plus h cubed, it's like quantity cubed, minus x cubed over h, which is the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. Now, I did that in my head because I happen to know Pascal's triangle, and I exploit the relationship of Pascal's triangle expansion of binomials. The leading coefficients are 1, 3, 3, 1. At this point, I break up the red marker. Why?
Cross out.
Because the x cubes cancel. Now every term that remains has an h in it. So let's factor one h out of each of those terms and wipe out this, that h, one of those, and one of those. Now I've got the limit as h approaches infinity of 3x squared minus 3xh plus h squared. What happens when all those h's goes to 0?
Everything attached goes to 0.
Everything that has an h in it goes to 0. The only thing that doesn't have an h
3x squared.
is the 3x squared. So there we have it. F prime of x is 3x squared. Now, if I ever want to know the slope anywhere on the curve, you tell me the x and I can tell you the slope. When x is 0, the slope is 3 times 0 squared. 0. Oh, that seems about right for that horizontal tangent. If I want to know it at this place, I plug the 1 in for x.
Oh, yeah.
Okay.
It's just 3.
F prime of 1 is equal to 3. Okay, so for that blue line, I know a point, and now I know the slope. So what's the equation of that line? Y is equal to 3
Quantity x
Quantity
minus
x minus
1
1
plus 1 plus 1.
plus 1. And that is the tangent line equation. And you can see, while I have it in this form, this is algebraically equivalent to the answer of 3x minus 2.
Mm-hmm.
Okay, what about the normal? Well, did we even define normal in class?
No. Well, it's just perpendicular to the
Normal means
tangent line.
perpendicular to the tangent. So going through this point, but at a right angle,
The reason why you like the point slope is because it's easier to get to the normal.
sure.
Because
It's easier to get
it's
to the
definitely
normal, and I
is
can read-
easier.
I can read the answer off right from what I'm given. Like, what do we know about the slope of the green line?
In it's the negative reciprocal.
Negative reciprocal of the tangent. So this is going to be negative 1/3 instead of 3. What about the rest of it?
It's
The
the same.
same. So the equation of the normal line is going to be y is equal to negative 1/3 quantity x minus 1 plus 1. I just leave it in that form. If it's a multiple choice question, then I'll start to algebraically manipulate it to make it a little bit nicer. But I like it in that form.
Solid.
Is that a better explanation than the other recording?
Yes.
And I think the difference in here is I gave a little bit bigger picture perspective.
You
Not
went
just
long
what-
division.
Not just to the answer, but why
You did long division.
I did long division.
Yeah.
That just, you lost me
What?
on that. Yes.
Side division.
What?
No, you said
Oh,
long-
we're definitely
you
getting
said-
rid of that recording.
You said long division.
I said long division.
Yep, and you did it too.
Yucko.
You have Stephen Hawking.
Won't do that again.
Yeah.
Let's
38,
let's replace that recording with this one.
38, 39.
Hey,
All right, can we close this?
Yeah.
All right.
terrible. I do.
I actually
Don't breathe. When he's
It's still recording, that's why.
Yes, I'll let